Thank you. As I'm sure everyone's excited now to get going. My name is Paul Reed. I'm a Principal Product Manager in the AWS Boston office, and I'm joined virtually today by one of my colleagues, Peter Levitt, who's a storage specialist solution architecture on the West Coast. We have a lot of exciting content to get through, and so I'll jump straight in. Today's topic is around hybrid storage and using AWS Storage Gateway to enable hybrid cloud storage. So I'll give you a little introduction as to what we think of as hybrid storage, an overview of the Storage Gateway service, and the three gateway types that we provide for file, volume, and tape. We'll look at some of the use cases, and we'll dive under the hood a little and look at some of the technical details of how the service works, just to give you a better understanding of how you can make use of the service within your own environments. To put this into context, in the center of the screen, you'll see three core storage services from AWS for providing file, block, and object storage. Amazon EBS provides you block-based volume storage. Amazon EFS provides you file system storage in the cloud. And Amazon S3 and Amazon Glacier provide you object storage. Those are our core storage services living in AWS. On the left-hand side of the slide, you'll see a number of services that allow you to get data into or out of those core storage services that live in our AWS regions. Today, we're going to talk about Storage Gateway, which is on the top left there. Once your data is in those core storage services, we have a variety of tools, either first-party tools from AWS or a number of partner tools that allow you to manage, use, and derive greater value from that data. Those are the topic of other webinars, and I'm sure you guys can follow those elsewhere. So what do we think of as hybrid storage? So when the cloud started, we had a lot of customers come to us who were what we think of as cloud native or cloud first. They built their applications in the cloud using cloud design patterns and cloud architectures. Those are all-in customers. The rest of our customers are customers who maybe have existing infrastructure. They love to be all-in. They love the value proposition that the cloud provides, but they have existing infrastructure in their own data centers today. And they are on this journey to get to the cloud. They'd like to be all in, but they need to straddle between their data center and the AWS cloud data centers for a short period of time. And for some customers, that's a very short period of time as they do a lift and shift and move to the cloud. For other customers, it could be a considerable length of time where their infrastructure lives both in their own data centers and within the AWS data centers. And in that phase, we call that hybrid, where you have workloads and data that lives in two places, or wants to live in two places. But your business needs to continue running, so you can't afford to just turn everything off, move to the cloud, and take your time doing it. So Storage Gateway is a service that allows you to bridge this gap where you have things running within your own data center and things running within the AWS cloud. So how can we make storage hybrid? That's the topic of today. Storage being a core component of any infrastructure, any compute infrastructure. It's the lifeblood, if you like, of your applications. So one way we can do that is with gateways. So what's a gateway? Well, a gateway basically provides you access to something. Here's a gateway that may be familiar to many, the Gateway Arch, which was a symbol of providing access to the West for the pioneers. But that's really not the topic of today. We're going to talk about Storage Gateway. Storage Gateway enables a series of hybrid use cases that allow you to take applications, workloads, devices, and users that sit within your data center or within your environment, your sites, your premises, and connect them to AWS. When the service launched back in 2012, many customers used the service for backup, disaster recovery, and archive to reduce their on-premises storage footprint. Storage Gateway provides storage in core storage services. Here we see Amazon S3, Glacier, and Amazon EBS, available to your applications through the service in a way that those applications can adopt it without having to make any changes. And we'll look at some of the technology that allows us to do that in a moment. As the services evolved and as customers get more comfortable with the cloud, and want to move more and more infrastructure and workloads to the cloud, what we've seen is customers using Storage Gateway for a much broader set of workloads, listing some of them here. The reason that Storage Gateway helps customers do that is that we provide native storage directly into the underlying core storage services that AWS has to offer. And so other services that can sit on top of that storage directly can use the data that Storage Gateway brings into AWS without having to be modified and without needing a gateway in the cloud to access that data directly. So Storage Gateway provides a way of bringing data into its native format and then allowing other services to access it and use it, allowing your business to move to that more of an all-in mode faster. Storage Gateway provides 3 types of storage, and we call these 3 different gateway types. File storage, where you can store and access objects in S3. Volume storage, where you can access traditional block storage on premises that's stored in AWS and accessible to you as EBS snapshots natively in the cloud. And Tape Gateway, which provides, in addition to tape storage for your on-premises applications, device emulation such that you can drop it in as a replacement for a physical tape infrastructure and start backing up your data to the cloud quickly and easily. No matter which type of gateway you're using, Storage Gateway has some sort of core capabilities, core tenants. On the left, we see the file, volume, and tape storage that I mentioned on the previous slide. Those are accessed through a gateway, a virtual machine that you download from the AWS Management Console. We provide that for VMware and Hyper-V. We also have an AMI for running it inside EC2 for applications that are already in AWS. That VM connects securely using HTTPS outbound from your data center to backend services that we host in all of our AWS regions. That service provides access to the core storage services of S3, EBS Snapshot, and Glacier. Between the gateway and the service, your applications can access that storage without needing to make modifications. The gateway provides access through standard storage protocols that your applications read and write data from. And the gateway and the service translate that into storing into the cloud services, the core cloud storage services, my apologies, using the APIs that are cloud native. The gateway provides a caching layer as well. So this is super useful for applications that potentially have low latency needs. So they can't suffer a round trip all the way to the cloud to get access to data. So we have a fully managed cache on the gateway that caches your hot data, your most recently accessed data, such that applications reading and writing that data can read and write at local latencies, at LAN speed, rather than at WAN speed. We fully manage that cache for you on the virtual machine that you deploy the gateway on. In addition to the caching, we provide optimized transfer, trying to move as little data between the gateway and AWS as we can. Now, this is important in environments where bandwidth may be limited, or in order to make data durable in the cloud much faster. The fewer bits we can move, the faster we can move any changes into the cloud, which reduces the potential for data loss if you were to lose your primary data center. We'll talk about some recovery scenarios later as well. As an AWS service, we're integrated with a number of other monitoring and management tools, such as CloudWatch, CloudTrail, IAM, and KMS, to do things like encryption, monitoring, alarming, and access management. I mentioned that Storage Gateway was launched in 2012, and we've had a steady cadence of launches since then, feature enhancements driven by requests from customers or use cases that customers have come to us wanting to use Storage Gateway for. The slide earlier where I showed the expansion from backup, DR, and archive to a much broader set of workloads, much broader set of active workloads, including analytics and data management. We had 12 launches last year. We expanded the service into some of our newer regions, and we added HIPAA eligibility to the service for workloads that require it. We had a number of other features across the file, volume, and tape gateway types. This year, we also haven't slowed down. We expanded into our AWS GovCloud US region. We've added eventing to the service through CloudWatch events, support for additional backup applications, and support for encryption through our key management service, KMS. Let's take a deep dive into File Gateway first. So File Gateway allows you to store and access objects that are stored in S3 from file-based applications with a local cache of data, as I mentioned earlier. This allows you to reduce your on-premises storage footprint, keeping all of your data stored in the cloud with a small cache of it local to your applications for lower latency access. We fully manage that cache. It's transparent to your applications, and we'll look at how reads and writes work through the cache in a moment. It provides you the durability and elasticity of storage in S3 without really having to worry about storage management on premises. Last week, and I'm excited to announce, last week we added SMB support to File Gateway, which has been a much requested feature for File Gateway. So we now support both NFS v3, v4.1, SMB v2, and v3, allowing both Windows and Linux applications to store and access objects in S3 through the gateway. In the SMB mode, access to the shares is controlled by your Active Directory, so the gateway becomes a computer on your Active Directory domain. You can do share level and file level access and permissioning to limit who can read what data from your S3 bucket. And we're seeing customers use this already for some quite interesting use cases, and my colleague Peter, we'll see a demo from him in a moment on using this new capability of File Gateway to do SQL Server backups. Another one of the things that we've added this year is integration with CloudWatch events. What this allows is a deeper integration of File Gateway into active workloads. So in the top left here, we see a File Gateway deployed in a Boston location. We see NFS clients in this instance that are writing data to that File Gateway. File Gateway is going to upload that data to S3. Now that could be backup data, in which case I just want to store it in S3 at the S3 price point. Or it could be data that I want to do something interesting with in the cloud, such as analyze it with Amazon Athena or Amazon Recognition. Or maybe even if it's backups, I just want to validate that my backup made it into the cloud. So one of the capabilities that we added earlier this year was the ability to be notified when the data from your applications on premises has been uploaded to S3, so that you can automate that downstream workload in the cloud. Using Amazon CloudWatch events, you can trigger Lambda, Athena, or a multitude of other things to know that your data is available to you and safe in S3 for downstream processing. We added another event to the gateway called Refresh Cache, which allows you to understand when data is available to your file-based clients that may have been written directly to S3 through an object-based workload. This allows you to then take an object-based workload that's generating data, putting it in S3, and distribute that S3 content out to other locations. Here in the bottom left, say a Seattle location. So the gateway now allows you to take both file-based applications and object-based applications and orchestrate workflows end-to-end between your premises and in the AWS cloud. Let's take a look under the hood about how the gateway works. So one of the interesting things that customers love about the gateway is this idea of one-to-one mapping between files and objects. So the namespace that your SMB client sees here is exactly the same namespace that you see in S3. This allows you to use those files, which have been stored as objects, with all of the native S3 capabilities, such as lifecycle policies, cross-region replication, versioning, and other capabilities, because the namespace is known to you. If you write a file called test.txt into the file system from your file-based application, you'll see an object in S3 called test.txt, containing the full contents of that file. Both file and object applications see the same namespace and the same data without needing to access through a gateway when you're talking to S3 directly, and obviously using the gateway for your SMB client. If you're on Linux, the same thing works. The files that your Linux NFS client sees are the same as the objects in S3 bucket in terms of the namespace. Really important, and it lets you access that data directly in S3 from any of the downstream applications. We give you a variety of controls over how your data is accessed and managed. So from the file side, we allow you to do things like client restrictions, either through AD or IP addresses. We allow you to create read-only file shares if you have data maybe that you want to expose to clients, but ensure they don't modify. We have a variety of settings that allow you to take data that was potentially already existing in S3, so objects that don't really have file system metadata, and add file system metadata to them as defaults, to allow you to control who can access what data. On the S3 side, the gateway becomes a client that's putting data into your S3 bucket, so you want to be able to control that. We allow you to configure the role that the gateway is going to use to put data into S3. You don't have to open your buckets up to a service credential. You control the role. It's a role on your account that the gateway will use to put data into S3. And a variety of the other settings that S3 has, such as storage class, such encryption, and things like guessing MIME types and request to pays, are all available to be configured on the gateway as it puts data into S3 to give you full control over how your data is stored. Let's unwrap the gateway a little and look at how it provides file-based access to objects in S3 and presents the illusion of a file system to upstream clients. Inside the gateway, there's two critical components, a cache of data and a cache of metadata. Let's first look at the cache for data and how reads and writes are handled by the gateway from your file-based application. In this instance, if my application tries to read some data, that read's always going to come from the cache. If the data isn't available in the cache, the gateway is going to fetch that data, write it into the cache, and then serve it up to your client, your NFS or SMB client. This instance, the only different from the client's perspective is slightly increased latency from that miss in the cache. Now, if the client was to go to reread that data, the data is in the cache, so it would see a low latency local read. So data is read through the cache. If the gateway needs to fetch that data, we try and do that efficiently. We talked about optimized data transfer earlier. We do minimal reads of data with a little bit of heuristics to do some read ahead if we see our application doing access patterns that we can predict. On the other side, if my application writes data, we have a write back cache. That means we synchronously write data to the cache, acknowledge your application that we've got the data, and then asynchronously upload that data into S3. For data upload, we try and again do that as efficiently as we can using parallel multi-part uploads of just the changed data. Super important that we just send the changed data. We're talking about moving around parts of files here, not whole files, which allows you to edit and manage a much larger data set on the gateway than exists in S3. You can take an S3 bucket with petabytes worth of data in it and access all of that data through a gateway that has potentially only a couple of 100 gigabytes of local storage. I talked a little about upload notifications. This is important to understand when we talk about writes. Because writes are synchronous into the cache and then asynchronous up to S3, how do you know when your data is available in S3 for the workload that might want to depend upon or act upon that data? So we added upload notifications through CloudWatch events earlier this year. This instance, my application writes some data to the cache, writes some data to the gateway rather. We put that into the cache. I can call an API on the service that says, tell me when that data is available in S3. When the gateway uploads the data to S3, he uploads it, and once complete, he then sends a CloudWatch event. This CloudWatch event allows you to hook to some of those other applications that are already native to S3 that can act upon that data, knowing that the data that your file-based application on premises wrote to the gateway is available to those applications in S3. The other thing the gateway does is caches metadata. Now, this is important when we start to look at file system operations that your client might perform, such as directory listings. Most applications expect directory listings to come back quickly, and they're pretty heavyweight operations, so I don't want to have to go to S3 every time somebody does a directory list. In this instance, we have a cache of that metadata of the shape of the file system, the keys, if you like, and the metadata associated with them from a file perspective. So again, when the client asks for this, the gateway is going to respond with whatever it has in the cache. If the gateway doesn't have information in the cache, we're going to do a list bucket, which gives us a listing of the keys in your S3 bucket for just that prefix that you asked for, just that directory. We're going to put that in the cache and then serve it up to your client. Subsequently, the gateway has that data in its cache. And again, this is a fully managed cache, so we're going to manage rotation of data into or out of it as your file-based application roams around the file system. Suppose you have an application that's writing data into your S3 bucket. That cache is not going to see that data until you tell the gateway to refresh its cache and check the data that it has in its metadata cache is up to date. We have another API call that you can call to tell the gateway to synchronize the cache with the S3 bucket. In this instance, he's going to perform the same list bucket operation for those directories that he knows about in order to tell the application that data is available to it. And again, we have another CloudWatch event on the back of that that will tell you that the gateway is up to date with the S3 bucket. And as we go into the demo, we'll see some of these events in action and we'll see data moving. So a lot of this may become much clearer when we demo it. So I'm going to hand over to Peter. Now, Peter actually pre-recorded this demo for a previous session earlier. So we'll hand over to Peter's demo.
Okay, so in this demo, we're going to take a look at how File Gateway's new SMB capability allows us to more tightly integrate with Microsoft Windows-based solutions. In this case, we're going to take a look at how we can back up SQL servers to S3 via File Gateway, just using nothing but the native SQL agent and File Gateway's new ability to serve S3 buckets as SMB shares. So here we have a diagram of an environment that I've set up. So I have a domain controller, a Microsoft SQL server, and a File Gateway VM all in one location. And what we're going to do is, or what we're doing currently, is we're backing up the SQL server via File Gateway into S3, so it's durably stored off-site in economical storage. So how this process really works is the SQL server attempts to connect to the SMB share on the File Gateway. It's then authenticated via the Active Directory domain controller, and from there it will write its backups into the cache of the local gateway, so it'll be nice and fast. At the same time, it's asynchronously being pushed into the S3 bucket into standard and frequent access, where it's available from there to do restore. We have a lifecycle policy so that after 30 days, we can lifecycle the older backups from Amazon S3 standard and frequent access to Amazon Glacier. Then after 7 years, with that same lifecycle policy, we actually expire and delete old backups that are no longer needed. As part of the backup process itself, once we finish writing the backup, the script that runs the backup process will then make a request to the AWS Storage Gateway service to get a notification when the backup that we've just written is actually complete and consistent in S3. So how that works is the request goes to the gateway service, which then initiates a CloudWatch event. From there, a CloudWatch rule populates an SQS queue when the object is complete and consistent, and the backup process itself monitors that queue. And once that's successful, we'll then log that success in the local server. When it comes to restoring the database, there's many ways we can do that. The simplest path, and probably the most likely path, is that you'll want to restore the database back to the SQL server in which you're backing it up from. And when you run a restore operation using the standard UNC path that's available through File Gateway, there's a good chance that if you're restoring a really recent backup, it's going to come directly out of the Storage Gateway's cache. If not, if the backup is a little bit older than that, then the gateway will actually serve that backup file out of S3. And then that's the process for restoring on-site to the same location where you were backing up from. But there's also, of course, the option, because this backup's off-site, to restore in other parts of the world or disaster recovery data centers, or of course in the AWS cloud. So one method is, you could deploy another storage gateway within an availability zone in the region that your gateway is registered in, and you could literally just do a very similar restore process that you would on-premise and restore into a SQL instance running an EC2. Another restoration path, and the one that we'll do in this particular demo, is we can spin up a new EC2 instance, and rather than going via gateway, because the backups are actually native S3 objects, we can use the S3 API to download the backup to the SQL instance and then restore it into the SQL server. And that's what we'll do for the restoration part of this demo. So this is my SQL server that we saw in the diagram. This is in one location. There's also a domain controller and a file gateway deployed in the same location. If I go to my storage gateway console within the AWS console, you'll see this is my gateway here. And if I go to the file shares, you'll see that I have this SMB file share, which is available over a UNC path. So I can directly map to this bucket essentially via this UNC path using the SMB protocol. And the share itself is backended by a bucket in S3 called PL SQL Backups US West 1, where it's located. So let's take a look at that. as you can see, I already have existing backups within the bucket. So I've actually been running these backups every hour. I'm doing full backups. Now, of course, you could do incremental backups and you could do them at a different frequency if you like. In this case, I'm backing up to standard and frequent access, and you'll notice that after a day, I'm life cycling my backups to Glacier. So this is already running, it's already doing its job, it's already protecting my SQL database. But now I'm going to show you the SQL configuration I have so you can see how we're using the native tools to create these backups. So if we jump into the SQL console, you'll see that I have my AdventureWorks database. This is a sample database available on GitHub. I can sort of just take a look at the properties so you can see that it's got some content. So that's my SQL database. I've actually created through the SQL agent the backup job itself, which is that process we looked at earlier on. So if we take a look at the process that we've created, it's actually a two-step process. So the first step is the backup process itself, which we can take a look at, which is essentially just doing a standard SQL operation to dump to this UNC path, which happens to be the gateway's representation of our S3 bucket. And then the second step, once that's completed successfully, is a PowerShell script, which is essentially making the request to get the upload notification when the backup is not only complete locally, but complete in S3. So what I'm going to do now is I'm going to manually, even though this is scheduled, I'm going to manually run this backup process so you can see. But actually it's not very visual, so we're going to run it for a second time after that using PowerShell. So let me just kick off this backup. So within the process you see running, there's actually two steps. That's somewhat hidden in the UI, but those two steps will be the backup process itself, dumping the SQL database to the UNC path, and then of course monitoring for the upload notification to know that actually the backup's consistent and restorable. So there you can see that the backup is complete. Now it wasn't very verbose. However, we can go to our application log, and if I refresh it, you'll see that the backup was completed successfully, and actually that the last step was to make sure that the backup was actually durable and S3 and ready to restore. But because we've used the native SQL agent, actually that exit code that says we're successful is available in the Windows application log, where your standard monitoring tools could pick it up. So like I said, that was a pretty non-verbose way to see the backup process. So actually I have a second process here, which is 100% run in PowerShell outside of the native SQL agent, so we can run that. And you can kind of see the process a little closer and how it works. And I might just keep the S3 console up so we can see the backup appear in S3 as well. In this case, I'm naming the backup something slightly different. So I'm naming it PowerShell_AdventureWorks, so you'll be able to recognize the backup when it's run. You'll see here's the name of the SQS queue that I'll ultimately monitor to make sure that the backup is successful. And that's the full UNC path that I'm writing to on the gateway to create the object itself. So if I just kick this process off, you'll kind of see the process flow a little more detail. So this is the SQL database being dumped to the UNC path, and now you can see we're waiting for the object to be consistent in S3, so we're polling that SQS queue so that we know when the object is actually complete and restorable. So now you can see the notification is complete. We've been able to retrieve the message from the SQS queue that says that the backup was not only successful but complete in S3. And if I go over to my console here and hit refresh, you'll see there's the newest backup that we just manually kicked off with PowerShell. So that's all good and well, but doing backups is one thing, and doing restores is what's really important. So now I'm going to do a quick demo of restoring this database, this particular database backup that we created in S3 to a completely different operating system. So an instance running in US West 2, I believe. So let me jump over there. Yep, US West 2. So this is a very vanilla SQL deployment that I've done using an AMI in our marketplace. The only other thing that I have here is a PowerShell script that I created earlier. And what we're going to use this PowerShell script to do is actually download that latest backup we created. So I'm going to paste the name of the backup into my script here. And we're going to download that latest backup from the bucket, which we were backing up to in the previous part of the demo. And we're going to restore that directly into SQL. So if I open my SQL server here, you can see I actually currently don't have any databases at all outside of the system databases. So I'm just going to run that process now, and you'll see that take place. So I've kicked off the restore, so that's grabbing the object from the S3 bucket, which is essentially the backup, and it's running the restoration process into SQL, all using the native PowerShell commands and the AWS commandlets. So I go over here and I just hit refresh. Here you can see I've restored the AdventureWorks database into this other SQL server running in an EC2 instance in a complete other location, in this case in US West 2. So hopefully from this demo you can see that it's really easy to natively back up Microsoft Windows or integrate tightly with Microsoft Windows thanks to the SMB support that we have. We can do very interesting things around writing directly to UNC paths, which essentially give us objects living in S3. In this case, it's for backup and recovery, but there are many other use cases that you could use to take advantage of the fact that you can now write to an S3 bucket via SMB. Hopefully you found it useful, and hopefully there's something you can take away and implement in your own environment.
Thanks, Peter. That was awesome. It's great to see how the new SMB protocol support on File Gateway can make it so much easier for Windows-based applications to make use of Amazon S3 storage. It just works how customers would expect it to. You use the applications that you're used to, and you can then store data in the cloud rather than storing on premises. So we're going to switch track a little. We mentioned at the top of the hour that there are 3 gateway types, so I'm going to quickly cover volume and tape. So volume gateway gives you cloud-backed block storage presented to your on-premises applications. So in cases where file-based storage isn't what you want, you need block-based storage. The gateway presents you an iSCSI target that your application can connect to and then can use for whatever purpose it wants. So this allows you to use cloud-backed storage on-prem with the ability to take snapshots in this instance, EBS snapshots. And those EBS snapshots can be used natively in the cloud or back on the gateway. We have 2 types of volume gateway. The first is stored. So stored allows you to keep your entire volume on premises. This is useful for applications which have low latency needs for all of the data stored on a volume. And in this instance, all of your data is going to be stored on a disk attached to the gateway virtual machine and asynchronously backed up to AWS. So if you were to lose that disk or you needed to use that disk in the cloud, all of that data is going to be durably backed up and durably stored in AWS and available to you as an EBS snapshot. So applications like databases or some applications that just have a very ill-defined working set and can't tolerate longer latencies are great applications for stored. Cached is very similar to how File Gateway works, where your on-premises storage can be much smaller than your amount of total storage. And the gateway will fully manage a local cache of just the hot data. A lot more applications fall into this category because most applications have a small working set of data compared to the entire data set. We provide a series of CloudWatch metrics to let you monitor the performance of the cache to understand just how efficient your cache is being and just how much of your data is coming from cache versus the amount of data that's being requested from S3. This allows you to tune the size of your cache to be appropriate for your workload so that in most cases, most applications will always see local reads. and will very rarely have to pull data from S3. Applications that have data reuse or are constantly rewriting the same pieces of data are ideal candidates for using Cache Gateway. I mentioned that Volume Gateway allows you to create copies as EBS snapshots of volumes. So let's look at how we can use EBS snapshots and a thing that we have within Volume Gateway called volume cloning in order to do things like restore, recover, and migrate volumes between locations using Volume Gateway. EBS snapshots are a point-in-time backup of the on-premises block device available to you in AWS. EBS snapshots can be used both in EBS to attach to an EC2 instance or back on Storage Gateway, either in your primary data center or potentially a backup data center. And that's sort of the transportable format for a block device within AWS. Volume clones, on the other hand, are a crash-consistent copy of your volume available within Storage Gateway. We've talked about how your volume data is always uploaded to the cloud. We want to be able to give you access to that data in case you have a potential problem in your primary data center and need to get access to that data. Cloning is one way of getting access to that data if you don't potentially have a snapshot or access to a more recent version of your volume if your snapshot is old. Let's look at 3 use cases for using EBS snapshots and volume clones. So the first is a traditional restore. In order to talk through this, let's look at how snapshots get created. With Storage Gateway, you can either create snapshots on demand using our API or console, or you can set up a schedule to have snapshots taken on a regular basis. No matter which mechanism you use to create your snapshots, snapshots are incremental. So in this example, we have a volume that's been written to 4 times over time, and there are 3 snapshots of it. The first snapshot, A and B were written to the volume. When C got written, snapshot 2 was taken. We only store the incremental changes for snapshot 2 because I already have snapshot 1, which contains A and B. So snapshot 2 just contains C, the incremental changes. When the third snapshot is taken, after D was written to the volume, I end up with a third snapshot again, which is incremental on snapshot 2, enabling you to reduce the amount of snapshot storage, but still provide you all 3 of those snapshots back if you need to restore data. So suppose we want to get access to the volume at a previous point in time. Maybe a user deleted a file or a file got changed and we want to get back to an old version of that file. In this instance, what I can do is I can create a new volume. In this instance, I'm creating it back on the same Storage Gateway from snapshot 2, which gives me the volume at that previous point in time. In this instance, I'm creating it on the same gateway. I could create it on a different gateway, or I could even create it in the cloud. That gives me access to older data to potentially pull that file off, maybe that was deleted or modified, and then go about my business. A very traditional backup and restore scenario. The second use case for these snapshots is to migrate data into the cloud. So we talked at the beginning about how customers are trying to get all in with a lot of their infrastructure and move workloads into AWS. So this often involves migrating large amounts of data. With Storage Gateway, you can take block devices, access them from your on-premises application, and use snapshots as a mechanism to cut over from an on-premises application to the in-cloud version of that same application, acting upon the same data that your on-premises application was using. Here we see the same volume that has A, B, C, and D written to it with 3 snapshots. If I want to now migrate that application server into the cloud, I can create a volume in EC2 from that snapshot and attach that volume, that EBS volume, to my EC2 instance and move my application over, acting upon now the same data that my application server on premises was acting on. So this allows you to migrate block devices from an on-premises application to an in-cloud instance of that same application with very minimal downtime through our snapshot mechanism. Third recovery scenario is disaster recovery. Now, in this instance, we're going to use volume cloning rather than EBS snapshots because that provides you the most recent version of your volume, irrespective of when your last snapshot was taken. In this scenario, I have a DR site. Perhaps that's in cloud, perhaps it's in another one of our AWS regions, or maybe you have a second data center. In that second data center, I have a second copy of my application and another storage gateway that's running and warm, but he has no volumes. If I was to lose my primary data center for some reason, or maybe I'm doing a DR test, so my primary data center is still running, I just want to make sure how would DR work if I was to have a failure. Using our API or console, I can create a clone of that live volume and surface that to the secondary copy of my application in my DR site. I don't have to take an outage on my primary. It's a live clone of the volume at the current state of the volume as uploaded to the cloud. So super useful for doing either real DR testing, potentially cloning test data, or other recovery scenarios where you just need to grab a copy of a volume in real time and act upon it. The last gateway type we're going to look at is tape gateway. Tape gateway is a little different to the other file and volume gateways in that not only does it provide you tape storage, but it also provides device emulation for a tape library. Simply put, tape gateway allows you to replace physical tape infrastructure with a virtual tape library running on a VM where all of the storage is backed up and safely stored in AWS. It's a drop-in replacement for physical tape infrastructure. We work with the majority of the leading backup vendors in a way that is integrated with their software. So by that, what I mean is your backup admin works with his backups through the backup application that he's used to working with. We've mapped certain characteristics of those applications into calling some of our APIs on the back end. So for example, when your backup application ejects a tape, the logical equivalent of taking a tape out of your robot, potentially sending it for offsite backup, if your backup application requests that, we take that data, remove it from S3 down into Glacier for lower cost archival storage. You can pull your tapes back from that archival storage in 3 to 5 hours, just as you would from your offsite backup vendor. Although in many cases, that's a faster turnaround than you would get from pulling a physical tape back into your library. Here's an example of the cost savings that one of our customers has seen from moving from physical tape to tape gateway. In this instance, there's a number of hidden costs, although for anybody that's used to tape, they're not hidden. Hidden costs are running physical tape infrastructure. You have a library to maintain, you have admins to maintain, you have offsite media costs. You've got to keep all of that data and all of that infrastructure fresh. By running a virtual tape library on AWS Storage Gateway, your admin time is reduced, your offsite backup time is reduced, and you're really just paying for the amount of storage that you have and not managing any physical infrastructure anymore. So the costs are significantly reduced. How does Tape Gateway work? Tape Gateway uses a cached model, very similar to volume cached and file gateway. In addition to providing access to that data, it provides tape drive and media changer emulation. It's worth noting here that all of your data is stored in S3, stored in AWS. The gateway is really just providing access to that tape data through those virtual devices that we're emulating. So again, if your gateway or your primary site is lost, you can restore your backups from those tapes that are safely stored in AWS. Ejects on applications are mapped to archival, so we move that data down. We have many customers that keep a very small set of tapes in S3 in their library and eject almost all of their tapes down to archive to reduce their storage costs significantly. So that brings us to the end. We've talked through file gateway, volume gateway, and tape gateway, and how they can help you adopt cloud storage as part of a hybrid storage offering. We've talked and demoed the new SMB capability on file gateway, which we're very excited about. And we've looked at some of the cost benefits of moving to cloud storage and hopefully helping you on your journey into the cloud. So with that, I want to thank everybody, and we'll stick around for some Q&A if we have time.